Welcome to my work solutions for the Edexcel iGCSE. As you can see, it's the paper 1 and still a bit of a COVID hangover. It does say copyright down the bottom, but they're still leaving the date out anyway. It's the Jan 2022 series, so let's get on with it. Question 1, inequalities. That's pretty obvious. So it says write down all the values. N is an integer, so just start on the left hand side and work your way through it. Is -2 allowed? Absolutely. And you just keep going until the integers are no longer allowed. We can't go to 3. Just make sure you include the 0. 0 is an integer. On this number line, the inequality y is less than or equal to 1. Circle, it's got the equal to bit, needs to be a closed circle. And I've read the mark scheme, by the way. If you only draw a line, it must extend. It's quite specific, to be fair. Must extend beyond the -3. But my advice, stick an arrow on it and it's all good. Number 2. As easy as it gets, really. Pick up your calculator. If the probability of winning a game is 0.65 and you do it 300 times, your best estimate or guesstimate, whatever, is times those two. You do 300 times 0.65 for an easy couple of marks. Number 3, bit more thought required. Here's my logic. You see that 16? There's 3 of them. So you can already start building up a picture that 16, 16 and 16 give you 48. What else do we know? Well, we don't quite know how big the square is, so that's your first problem. And neither do we know how big that is. But you can work it out nice and easily because it's a hidden Pythagoras question. So, for example, if I call that x, how do I work out the size of x? We've got to do the root, because it'll be 16 squared on the hypotenuse, minus 12.8 squared there to give you the shorter side x. So you stick all this in your calc, and it comes up with a pretty nice, straightforward 9.6. So you've got a 9.6 there and a 9.6 there. Add that on. 2 lots of 9.6. Or what is it, 19.2. But you've still got that. Now that is not 9.6. That's 9.6. You need to do 12.8 minus the 9.6, which gives you the extra, the final length required for the perimeter of adding on 3.2 to get 70.4. On we go. As always, there's no chance of me ever being successful of drawing certainly a freehand graph with a chuffing electronic pen, so not even going to bother. I'll talk you through this though. When you substitute in negatives, do be careful with brackets. So I would type in bracket, open brackets, -2, close brackets squared, then -4 times brackets -2 and so on. Make sure you're doing it properly or do it one thing at a time. All right, because unfortunately, with a quadratic, there is normally some symmetry, both in the graph and in the table. So you have got, if you work these out correctly, there is some symmetry going on, as you can see, around the -1. So -1 is going to be where the vertex is, in this case, the minimum point. And so you've got symmetry, 0, 0, 3, 3. But unfortunately, you've got to work this out, unless you realised that it's going to have the same result as subbing in 6. So you could do 6 squared, but a bit of a sledgehammer to crack a walnut scenario. Stick it in your calc, use brackets, get 15. When you're plotting, plot the coordinates and do your best. I'd always recommend doing it with a pencil first, just nice and slowly. You need to be within half a square, so do have another go. Take some practice these, but there you go. I think I actually did first time ever. I actually did a reasonably good job on that one. But on we go. Number 5, one of those puzzly questions. So we've got 5 numbers, but he's sat 8 exams. Now, I will just say there's only one set of solutions for this. All right, there's only one possible outcome here. The first thing I went to is that if the mode is 80, there's got to be at least one other. Now, there might be another 80, so you can't. But then I thought, well, if I want the range to be 16, let's go down here. Let's assume 80 is the biggest. Let's take away 16 and you get 64. But the real clue, now you've got 7 numbers, the 4th and the 5th number must add up and halve to give you 74. So that's relying on this number 75, because 75 at the moment is the median. It's slap bang in the middle of these 7 results. So you need to put a number. There's not going to be a number in here, because that'll move the median up. You need to insert a number here, because that will make the median 74. You've got to slot in a 73, and that's what will give you the median of 74. So these turned out to be correct. So in any order in your answer, 64, 73, and 80. But it's one of them where you just go with educated guesses. They're giving you plenty of room to play about with it. Have an educated guess, see what happens. It's a 4-marker. Play around with it for 5 minutes. Number 6. Now, 2 choices here, factor trees and then all that malarkey. But with them being reasonably friendly numbers, I'd just grab your calc. I would get the 36. And because 120 ends in a 0, your answer must. Because it needs to be an answer in your 120 times table. So you don't have to write them all out. Just keep adding I have on my worked answers, by the way. Just keep adding 36 until you get numbers that end in 0. So 180 is a possibility, but 120, nope, doesn't work. The next one ending in a 0, you'll get to the 180 doubles, and that's the answer. 360. But you don't have to waste your time writing them all out. You've got a calculator. Make sure you make best use of it. Next part. This is a weird looking question, but don't get put off by it. The idea is to find the highest common factor when it's written in prime factor form, index form, you always just pick the lowest value. All right. So if you consider the power of 5, what's the highest common factor? Well, m has to be greater than 2. It means it could be 3, 4, 5, you don't know. But who cares? You have to pick the lowest, because it'll be 25 that is the common factors. Can't go any higher, because another 5 doesn't go into A. So now when you look at, I'll do P next. So now when you look at P has to be greater than 1. So P is going to be 2 or above. But it doesn't matter, because highest common factor, it needs to be in common. So 11 for A could be any power you want. It doesn't matter. You pick the lowest. Like so. You obviously don't need the 1. And with a bit of jiggery pokery in the middle, n must be greater than 10. So let's say it's 11. You'll have 7 to the power of 6 in there, or more. But it doesn't matter. You pick the smallest. So they're just trying to muddy the waters there. Don't let it put you off. When you know it's just pick the lowest, it's actually not a bad question, but it is a non-standard question. So plenty of people will have got caught out by that. Number 7. If ever there's an overly complicated question, wordiness for the sake of it, as soon as I see a wordy question like that, I start organising. So they've obviously called the places A, B, C, D. So think about the journey AB, BC, and CD. And it's obviously a DST question. So create yourself a little table. Help yourself out. Knowledge, as far as AB goes, we're told 245 in 2.5 hours. For BC, we're told 220, but it's a speed of 80. And for CD, we're told it's 72. But 50 minutes is a bit of a trick. How do you put 50 minutes in your calculator? It's not 0.5. Stick to fractions or decimals. It's obviously a horrible decimal. Stick to 5/6. Work out Millie's average speed. Now, if you're going to work out average speed for the entire journey, you can't just add that column up. Nonsense. Average speed is total distance up there divided by total time. So the gaps you need to fill in, you could have filled that gap in, but you've wasted your time. We need this gap. So how do we work out time? 220 divided by 80, you get 2.75, 2 3/4 hours. Now we fill in this blank here. To get distance, it is speed times time. You multiply those two, you get 60. And now you're getting there. Total distance is 525. Add up this third column in your calculator. My calc gives me the lovely fraction of 73/12. It wants one decimal place. Answer is 86.30, etc. 86.3. On we go. Bit of standard form. A and B, pretty standard, no pun intended. Don't forget, powers of 3 are always important. So power of 3 would be thousands. So power of 4 is tens of thousands. Or if you're a fan of loops, it's moved 4 times. That's a bit too many, but there you go. Do the loops if you need to. Loops probably help a bit more here. You need the number 6. You need the power that's going to be a minus because it's a small number. And you would need to move it 1, 2, 3, 4, 5 times. Job done. Now you might have a better calculator than me, but when I stick in powers of 500-ish and 700, my calculator tells me to go elsewhere, doesn't like it, math error. So I have to do this. The non-calc way, rarely, but you do press your calc. Do 4 divided by 1.6. Luckily, you get a number between 1 and 10. And when you divide these, you subtract the powers. So 512 minus 700 gives you the lovely looking answer of minus 188 for your power. Bit more on laws of indices, because obviously standard form does include some. When it's multiplied, you add the powers. Power to a power. Do the numbers first. Calc or mental arithmetic, or maybe you just know that 4 cubed is 64. And then you've got y, and the powers should be multiplied. so it's power of 6, not 5. And for part C, it goes to a quadratic factorising, 2 brackets, ends at the beginning because it's a standard one, and you rack your brain for two numbers that multiply together to make 12 and add together to make -7. You've got space, or you might, they're pretty standard numbers. You've probably done the exact question before. On we go. Number 10. What a load of waffle. Gonna paint the outside. Stop. Just stop right there. Don't read on. If you carry on reading, you're just going to dig yourself into a bigger and bigger hole. If you're painting the outside, it's a surface area question. The only bit that's important is not doing the base. So your job for surface area, there's a front, there's a back. So you need 3 times 2.5 doubled. That's the front and the back taken care of. Left and the right, there's 2 of them. So it's going to be 12 along, 3 up. We can do that bit in our heads, can't we, folks? That's 36. And then we've got the lid, because that is shaded in. But we don't do the base, so no need to double it. So the lid is 12 by 2.5 on your calc. What's that? 12 doubled is 24. Add on 6, it gives us 30. As long as you get a total answer of 117 metres squared. And a little bit of advice on these questions. You don't need to put the units in early on, but I do think when it's really waffly and long-winded, if you write the units down, it makes it, it's much clearer where you are in the question. Because think about it, how many times have you done a question that's like this, wordy, waffly, and you've gone, yeah, I've got a number, I don't exactly know what it is, what it's referring to. And you waste 2 minutes reading the question again. So there you go. So all this, waffle, you need enough paint, waffle. Each tin of paint covers an area of 15. Don't read on. Do some maths. Total surface area divided by 15 gives you 7.6 recurring. We have to round up. Even if it was 7.1, it would round up. We're not leaving something unpainted. So he's going to need 8 tins of paint. Now it morphs into, before the increase, the cost of each tin of paint recently increased by 10% after the increase. So you've got this problem. You don't know the original amount. It's morphed into a reverse percentages question. If something's increased by 10%, your multiplier is 1.1. But as you'll know from reverse percentages, although we refer to it as a multiplier, you work backwards. You need to divide by 1.1. And that means before the price increase, each tin of paint was £24.50. Well, Jonty needs 8. Do that sum. It means he's right, but show that Jonty is correct. So you've actually done there. You don't need the sentence. It's not one of them that's asking you a yes or no. On my work solutions, I did just put which equals cost before increase, but you don't have to. You've got there. Show that Jonty is correct. That number 196 shows that Jonty is correct. And we didn't need that page. So number 11, got to admit, pretty formulaic. I think these are easy, folks. If you're not sure, get it revised. Nice, easy 2 marks, in my opinion. It's part of a circle. It's fraction of a circle. So you start with the formula for the area of a circle. Pi times the radius squared. But because it's not a full circle, What's the fraction of the circle that we're using? It's 110 360ths. Calc says 48.39. So 48.4 it is. Number 12, one of them cubics, but a little bit easier because there's not 3 brackets. So I always go for the brackets on questions like this. If there's 3 brackets, just pick any 2, but there aren't here. So I'm just going to expand these. So n times 3n. I always do the numbers next. Minus 4 times 5 is minus 20. And then I do the n terms in my head. So we've got negative 12n. And then we've got to add 5n. However you do your loops, no one cares, as long as you get minus 7n. And all these 3 need to be multiplied by n. So we get 3n cubed minus 7n squared minus 20n. On we go. Algebraic fractions. Now, different teachers do these different ways. Some of you might have multiplied your bottoms, your denominators, and ended up getting 8x squared. Now, it's not wrong. It just means that it will cancel down more at the end. So if you can find the lowest common multiple, that's the best one to use. So x, 2x, and 4 all go into 8x. It's the lowest thing possible. All right, oh, you could, hold on. 4x. I've done 8x on my thing. I've just had a whoa's mind blown. Sorry, folks. They all go into 4x, obviously. If you look at my work solutions, you'll see that I haven't. But no one cares. It cancelled down at the end. We'll all get the same answer down here. Anyway, let's shut up and get on with it. So left-hand term times it by 4. So do the same to the top. Middle term, double it. So do the same to the top. Not even any minuses to worry about. On the right-hand side, that 4 that I've scribbled out kind of just needs timesing by x. Do the same to the top, 1x. And it all simplifies nicely. 3x on top, 16 as well, 4x on the bottom, and there we go. Well, I've amazed myself. Number 13. So it starts off pretty bog standard. There is a part C and so on that's a little bit of a thought process, but here we go. Let's earn the easy marks. That's 5/12. Weird how they've kind of left half of it. Anyway, 7/12 and 5/12. I'm not going to scroll down for B. Probability of both red is bottom times bottom. In other words, 5/12 multiplied by 5/12. And you get 25 over 144. Now, before I scan ahead, knowing what comes next, I'll just mention there's a very waffly question coming next. I'll go to it in a sec. But just mentally, it's about green and red and red and green. So notice that it's 5/12, 7/12, 7/12, 5/12. Here's why. So that's about as waffly as a question can get. More like a poem. All right. But it's a load of nonsense. At the end of the day, she's got blue, green, and red. The guy before, all right, didn't have all those 3 colours, don't forget. Only had the 2, the green and the red. Didn't have the blue. So the idea is, Hector's as waffly as you get. Basically, Hector picks a counter, puts it back. He picks another counter, puts it back. And then Megan goes into her jar. So it's all about Hector first. Now, the probability that the 3 counters are different. Well, let's look at the probability that Hector's are different. So as I've already mentioned, Hector being different is 2 lots of 7/12 times 5/12 because it was order is important. There were two routes to get hectare having different counters. So that spits out 35/72. So the idea is, in order for Megan to be different, she can't pick a green or a red because he's already accounted for them. It's all about she's got to pick blue. That's all we care about. But we don't know how many blues there are. But we do know that hectares being different multiplied by Megan's being different, its unknown blue out of the 15 counters must equal 7/24. There's your equation set up. Get it solved. So leave your x where it is. I just did it all on my calc. 7/24. I multiplied by 15, multiplied by 72, divided by 35. Spits out a lovely looking answer. We know we're right. Number 14, as with all these, I'm not sitting here or making you listen to me write out these long-winded words. People hate writing out the reasons. One word. Tough. Do it. But because I've already done it on my worked answers, go check them out. I'm just going to talk you through them here. So firstly, the angle ABC is 90 because it's an angle in a semicircle and that's a right angle. And then using angles in a triangle make 180, we know that that is 35. And this extra line, if you ignore that now, this shape here, let's go to a different colour. If you create an angle like so, and you create another angle like so, this angle is also 35 because angles on the same arc are equal. Yes, you don't like writing. Tough. It's 4 marks. Earn it. Number 15, using algebra. So first thing is, it's consecutive whole numbers, so no need to worry about 2n, evens or odds. It's none of that. It's simply 3 consecutive numbers, n, n plus 1, n plus 2. The sum of the squares of the smallest and largest. Stop. There's the smallest, square it. There's the largest, square it. So first one, n squared, and to square this, square the first, square the last, times the two together and double it, and let's simplify. Is always 2 more than twice the square of the middle number. Here's the middle number, there's the square of it, and that's us doubling it. So square the first, square the last, times the two together and double it, and now double everything. Oops. Looking ahead, double 2n, you get 4n. And oh look, if we subtract 2 from there, hey presto, that's it. It's only 3 marks, and all that algebra is getting you plenty. So say something right at the end, as in equal, equal, difference of 2, or words to that effect. But don't over waffle. You've done the hard work. Number 16. As soon as I see that, I just go. So A is 1, D is 4. Now here's the little thing, by the way. If we were to add up the first 6 numbers, we'd get an answer. All right, what is it, 21. Now if I said to you, only add up the third term to the sixth term, it's not the third term you minus because that's included. It's the second term. Why am I saying all this? Because the 41st term is to be included in your answer. So what you're essentially going to do is find the sum to 100, but then you need to subtract the sum to 40, because the 41st term, it's inclusive. So flip to your formula sheet. You've got a formula that goes n divided by 2, 2 lots of a, plus n minus 1 times the difference. In your calc, 19,900. Onto this, exactly the same process, but this time n is 40. So it's n over 2, 2 lots of a, plus 39 lots of 4. We get 3,160, and they are to be minused. 16,740. A nice question if you like your series, but don't fall into that little trap they've tried to set. Number 17, some Venn diagram set notation malarkey. Not a bad one, this. Helpful to make lists, as you'll see in a sec. So they represent the number of elements. Let's go. The number of elements A union B. There's A, there's B. Don't include numbers twice. So when you add all them up, you get 19. Now, intersection of A and C. A and C, intersection means crossover. They don't. Now we start getting even more tricky. B intersection C dash. Well, I think it's easy to make a list. What is in B? It's got a 3, an 8, and a 2. What is inside, or sorry, in this case, outside of C? 6, 3, 8, 4. Whoops. 6, 3, 8, and 4. And intersection means crossover. What do they have in common? A 3 and an 8 for 11. I'll have to scroll down so the numbers will disappear, but you already know it. The union of outside of A, outside of B, outside of C. I just listed them all. I know it's a mark, but it's tricky now. We're question 17, part 4, so it's bound to be a little bit tricky. The numbers outside of A are 4, 8, 2, and 5. The numbers outside of B are 4, 5, and 6. The numbers not in C are 4, 6, 3, and 8. But when you are unioning them, that's a word, trust me. When you're adding them all up, you don't add up numbers twice. So the fact that 4 appears, just count it once. There's an 8 there, count it once. There's a 2, there's a 5 there. So again, count it once. There's a 6 in both. You only want to count it once. So add up the 4, the 8, the 2, the 5, the 6 and the 3. We've got 28. I am rubbish at 8s. That's not great either. Anyway, number 18 is all about linear scale factor. So when you've got this top bit of info, let's look at surface area going from A to B. How do you turn the number 4 into the number 9? You multiply it by 9/4. That's your area scale factor. It needs to be square rooted to find your linear scale factor. Square root of that is 1.5 or 3/2. We need to repeat now All right, for volume, when you go from A to B, what's your multiplier? It's a bit less obvious here, but I always say times by the number you want to get, divide by the number you had. And these are suspiciously cube numbers. So when you cube root them to get the linear scale factor, you get 7/5. You're now ready to move on. Work out the ratio height of A, height of C. Let's just write them all down. A, B, C. Now we haven't got some numbers. We've only got multipliers. What we're going to do? Make up A. Everything relies on A. Now if you called it 100 and times it by 3/2 and then it'd be fine. Not a problem. But why not? Why call it 100? They're all in proportion. The bigger the number you call it, the more it'll cancel down at the end. So, yeah, call it 1. So to go from A to B linearly, again, that's a word, you just times it by 3/2. And if you want to go from, whoa, did I write A to B here? I obviously meant B to C, but there we go. I apologise. So to go from B to C, you take B and you times it by 7/5. You get 21/10, which looks horrible, and you don't write ratios. I mean, there are questions where they use decimals and fractions. I always hate them. Should have integers. For me, if I was Prime Minister, that'd be my first law. We're only interested in C, so let's times both numbers by 10. And we get those integers that I am desperate for. 19 part A. Yeah, a tricky looking, a non-standard one, but if you know your integers, if you know your indices, should be okay. Do it one layer at a time. 1/x means x to the power of -1. You've got all that raised to the power of a cube root. Power of a cube root is a third, and power to a power means multiply, which is all to the power of 4, and power to a power means multiply. So that's it. Times all them together. Use your calc if you need to. On to part B. They love completing the square, everyone. If you don't revise completing the square, you're chucking away marks. Very, very standard. Comes up on every paper. Sometimes they're even more tricky than this, and they have minuses and all that malarkey. This one's tricky in one hand because it's got a 3x squared, but it's one of the better ones because there's no problem with numbers going into fractions or any nonsense like that. My advice is leave the plus C bit alone. We know that will change. Let's just work on the completing the square, which you can't do if there's a number next to x squared, but you can do when you get it like that. So in the square brackets, we halve the number next to x, we square it, take it away, and now we expand. 3 lots of those brackets, and 3 times -4 is -12 plus the 19. Job done. Get revising that if you hate it. Number 20. So part 8. Just stop for a second, always say to yourself, what does a +5 do on the end? It's actually nice. Its vector form would look like that. It doesn't move it horizontally, it moves it up vertically. And vertically, it's the correct way around. I'm saying that because horizontally, plus and minus, you do need to be careful there. So if you move everything on a graph up 5, that will not change the x ordinate, but it will add 5 to the y ordinate. There we go. So in this case, if the 3 was in front, that's the one that does that. This ain't. This 3 is next to x. So if it was a sine curve, if there's your sine curve, it trebles the number of sine curves you get. Whoops. Okay, so what it means is it squishes it with a scale factor of 1/3. That's a hell of a 3. It was meant to be a line with a 3. So that won't affect its height, but its x coordinate will. Times that by 1/3, it's -2. And now a rarity. I've decided to actually draw a graph live, but it's best to explain it. So what does a 2 in front? Now I've mentioned, if that's the sine curve, you'll have seen 2 sine x and so on, 3 sine x and so on. A number in front of a graph does that to it. So all the y coordinates need to be doubled. So this one is down 1. It goes to there. These, you double nothing, you get nothing. It stays where they are. This -2, what the heck am I on about? This +2 doubles to cross at 4. This 2 up here goes up there, and so on. Now bear with. Get your ruler, get them lined up. There's part 1, and there's, part 2. I hate when it clicks into place, so I don't do it live. But there we go. You've got your graph of that transformed. Next. This one, quite weird in terms of how to go about it. So I was reading this one for a little bit. I thought, I know it's only 2 marks, but it's worth a thought. I was thinking how best to explain it. So because it's a plus A, that's the thing which moves it left and right. So I thought the best way to explain it is, there's the x-axis, -1's important, 6 is important. The graph of the transformed passes through the point 2, 0. And there we go. So to go from there to there, that's moving left 4. Don't forget, left 4 is +4. This would need to move it right 3. To move it right 3 would be -3. And I hope that's got that idea across nicely. Back to some basics. There's always a histogram somewhere to make a bit more sense. As you can see, it's one of them because there's only 3 types of histograms, and one of them is where they don't give you the frequency density. There's your first job. 16 melons are in there. So you need to work out the height of it. If the area is 16, the width is 0.5, the height is 32. So that's got to be 30, 20, and 10. And now it's a case of, how do we work out the total? You need the areas of the other 4 bars. I've set it out nicely on my worked answers. Not going to bother here, just going to shout out the numbers. So for the first bar, it's 1 wide, it's 15 high, 1 times 15. Second bar is 1 times 23. Next bar is 1 times 30. And the next bar, the final bar, is 1.5 wide, 12 high, 18. Get all them added up, not forgetting to include the 16 that you were given, and you should get 102. Number 22. Horrible in my opinion, but let's just stick with it. Very much got to go logically on this one. The tough bit is that you actually want this angle here. Okay, so let's not forget that angle there is 180 minus the other two. That will come into play. As with all my videos where I do an errors and bounds, pick up the easy marks by writing your menu. So C, 1 decimal place, could be as big as 11.55 and as low as 11.45. X, whole numbers, so go up and down by a half. And Y is also whole numbers, so go up and down by a half. And this is one of those errors and bounds questions. Normally they give you a formula. This is the one they haven't done here. They've just said upper bound of B. Well, let's just take a step back. In a question where you've got an angle-ish and the opposite side-ish, it's a sine rule question. So let's just think. B over sine B is going to equal C over sine C. Now let's consider, but let's just rearrange it. We need the upper bound of B. That's what we're after. So I'm going to multiply both sides by sine B. And here's my logic. Hopefully it makes sense. To get the biggest value of B, I would need to pick the largest value of C to multiply it by the largest value of sine B, which is this here. How on earth can this be as large as possible? Well, it would be 180 minus the smallest x and y's that you can think of. So little x, and little y. All over. If you're looking to maximize something, if you've got to divide, you want to pick the smallest possible. So that's the logic. Now, you don't have to write that in the exam, but that's the thought process that I think helps you on these. You know, we're on question 22 now. It's tough going. We've now got numbers that we can plug in. So the largest B, big C is 11.55. The biggest this can be would be 180 minus 74.5 because we want small y and small x. All over. We want the smallest, so it's sine, again, small, 74.5. 3 significant figures. Calculator spits out 5.254-ish. It goes on. 5.25 gets you the marks. Yeah, tricky, but follow the logic. Try and stick to logic, all right? Yeah, it's quite tricky. Doesn't give you a formula. Unfortunately, that's your job. Number 23, a non-standard, in my opinion, weird differentiation. So to differentiate, you bring the power down, you take one off the power. So ds, differentiating this with respect to the variable t, bring the power down, take one off the power. Bring the power down means 2 times 4, take one off the power, and 5t just becomes 5. So the idea is, let's get it factorised. Let's not worry too much about greater than 0. I have done that on my worked answers, but I'm starting to second guess myself on whether that's the right way to explain it. Get it factorised, use the AC method if you want. As I've just said, I'm afraid I've already done this question before. So the critical values of t are 1 and 5/3. Now, before we worry about what the hell that means, move on, differentiate this one. So differentiate, because x and s are interchangeable. They both mean displacement or position, whatever you want to call it. So differentiate again. This one, though, works out a bit easier. 2t minus 4. So you get the critical value of t equals 2. Now, the idea is that they are moving along a straight line. So, but doing that's something like that. Obviously, that's not exactly right, but they're moving the left and right. So, in order to be moving in the same direction, they both need to be going, both need to be positive and so on. So, again, I've thought long and hard about how best to explain it. The mark scheme does a terrible job, if I'm honest. So I went for the number line approach. Let's see if this makes sense. There's 1, there's 5/3, and there's 2. 2 is linear, so it's kind of doing that. Just for example, when t is 1.7 or some rubbish, it's negative. When t is 5 or something, it's positive. So that's what it would look like. All right. Similar to this one, though, this is a quadratic. It's a positive t squared, so it looks like that. Why does that help us? Now, if they're travelling in the same direction, they either both need to be positive or both need to be negative. So, above 2, they are both positive, because this one just carries on. So when t is greater than 2, terrible writing. Sorry, folks, we're nearly at the end of the paper. T is greater than 2 is when both graphs are positive. It's between 5/3 and 2 that one graph is positive, one graph is negative. That's where they are not heading in the same direction. They're in opposite directions. But when we go to the left of 5/3, they are both negative. In other words, they're both travelling left. So it's when t is less than 5/3. Now, they've already given you the constraint. Mark scheme, they don't actually need you to include this. They do include it in brackets, so it's kind of optional because they've already defined that t must be greater than 1. So actually, you don't need to worry about that, but who cares? So I'm really hoping that got the idea across that they are both travelling to the right when t is greater than 2, and they are both travelling to the left when t is between 1 and 5/3. They are in opposite directions in that region between t is 5/3 and 2. Whoa, as I say, I'm afraid the mark scheme is useless at explaining that, so hope I've done my job there. Oh, there was more space for that, but there we go. Number 24, we're nearly finished. We've got a 5 marker. Bit of a it's not the hardest vectors question, but it's a tough one. O to x is a, so the m's in the way. So let's stick it on there. X to y is b, and that's 3b. So all that's gone. M's the midpoint, so that's in a 1:1 ratio, so halves you could write on if you want. N is on the point, so that's a who cares. Diagram is not accurately drawn, but it can't be drawn to mislead. So we already know that. Given that O to N, O to Y is that. So get that on your graph. O to N is lambda, So let's say that lambda is 3/5. This will be 2/5. I know it looks bigger and all that, but it's not accurately drawn. So whatever lambda is, this bit over here is 1 minus lambda. Now you can start building it up. I always say, when you've got like a triangle and you've got two sides of it, always think about the third side. So O to Y is A plus B. Nice and easy. Let's also think about how we get, because always look at lines, you could think about Y to Z, but I'm going to go for M to Z. So to go from M to Z, it's negative a half A plus 3B. So we've got that line, we've got that line. What else can we do? Now the key to this question is you've got to set up an equation. You've got to bring into play, in this case, simultaneous equations. Why is that? Because Z's got to play a part somehow. So you can call it any letter you want. The mark scheme uses mu, so I'm going to use mu as well. Also on the mark scheme, it's got lots of ors. There's about 7 or 8 different ways. Depending on how you start it, there's loads of ways of doing this. Obviously, I'm only going to do one of them. The way I would go about it, if it all hinges on getting to n, we need to write a couple of ways of getting to n, and we need to be able to say that these two things are equal, and we can use the technique called comparing coefficients. So, as I say, there's loads of ways of doing this. This is not the only correct way. It's the way I would go for it. I think it's the easiest to explain. Let's consider how we get from m to n. But let's go the long way first. So we go minus a half a and we go a bit of OY. That bit is lambda, lots of OY. Then you've got to say, is there another way of getting from m to n? Yeah, there's the more direct approach here. Now that's a fraction of m to z, which is why I kicked off with that. Another way of getting from m to n is that way, and that is mu lots of m to z, so minus a half a and 3b. So you have two routes of getting from m to n. These must be equal, which means these must be equal. And the method of comparing coefficients says if that's the case, then the coefficient of A must be equal as well. What the hell does that mean? It means the numbers next to the A's here, so that's minus a half, and here, so if we expanded it, it would just be a lambda, because lambda is a number, we just don't know it. And down here, if we expanded it, what would be next to A? Negative a half mu. But then we do the coefficients of B. Now this is actually the easiest one. Some might have gone for this first. Same again. Whatever is next to B in this top equation, well, it's just a lambda then, must be equal to whatever is next to B in this bottom equation. And if you expanded it, it would be 3 mu. As you can see, that is going to be a nice, easy thing to substitute in. So let's put the second equation into the first equation. So we're replacing lambda with 3 mu. We've got an equation, one variable, it needs solving, adding a half mu to both sides, adding a half to both sides, times both sides by 2. As you can see, that makes mu 1/7. It didn't ask for mu, it wants lambda, but that's going to be easy because lambda is 3 lots of mu. But why would you write that when you can just go straight to 3/7? These big vectors questions, they're never easy, but I have uploaded on my YouTube channel, just to self-promote for a sec, 10 vectors questions, and there will be more to follow by the time I'm recording this on October the 14th, 2025. There will be more to follow in future days, weeks, months, and centuries. Maybe not. Anyway, I hope some of the explanations on that has helped, because I certainly don't think the mark scheme does. I'll see you on the next one.